So hello everyone, my name is Aryan Tiwari, and in this video we will discuss about what is machine learning, different type of machine learning, and implementation of every algorithm of machine learning. So first I will show you the types of machine learning. So there are basically three types: supervised learning, unsupervised learning, and reinforcement learning. So basically supervised learning deals with the labeling of the data, like it is used for the data which is labeled, and it is classified into two parts. First is classification, second is regression. So we use regression basically for continuous values, like the values which are continuous, like age, height. These are the continuous values, and we use classification for the categorical values, like the class labels. So I have also given the example of every algorithm. So in regression, we can use weather forecasting, market forecasting, population growth prediction. So all these things come under regression. In classification, we can do image classification, diagnosis, identify fraud detection. So these are the supervised learning methods. So the second type is unsupervised learning. In unsupervised learning, the data is unlabeled. So we need to tackle with the unlabeled data. And the famous example of unsupervised learning is clustering. So I will tell about clustering. So clustering is used in the k-means algorithm, the algorithm which is used to group similar values together. So we will go in detail with every algorithm in the upcoming slides. I am just giving the overview that what are the machine learning algorithms and what are their uses in the real world data. So in clustering, we can use it in recommendation systems, target marketing. All these things come under clustering. Apart from these, there is also hierarchical clustering, DB scan. All these are unsupervised learning. We will go through of every algorithm in the upcoming slides. So I forget to tell about dimensional reduction, which is used for the PCA part. And the third learning is reinforcement learning, which is used with the agent of environment. So basically our focus will be on supervised and unsupervised learning methods only in this video, in this presentation. So I will move forward. So this is what is machine learning. I had already told you it is the study of computer algorithms which can automatically improve experience of the user of the data. So in easy words, I can tell that machine learning is based on a sample data, which will make the predictions and decisions with what you give inside it. So this is like a short definition of machine learning. The types I already told you: supervised, unsupervised, reinforcement. So supervised, I previously told you that it deals with the labeling of the data. So we work on our labeled data in supervised learning. So now I will tell you the types. Types are regression and classification. So regression is used to predict the continuous values. You can see it continuous values, and some famous examples of regression are linear regression, logistic, ridge, lasso. All these are regression algorithms. Logistic is also used in classification because of its categorical values and variables. So the second type is classification. So the classification algorithm is also supervised learning, which is used to identify the category of new observations. In simple words, you can say that it is used for categorical variables, and regression is used for continuous values. So some examples of classification are naive Bayes, KNearest Neighbors, KNN, decision tree, support vector machine. So these are some examples of classification problem. So now we will go in depth of every algorithm. Before that, we will also learn about the unsupervised machine learning. So unsupervised machine learning, as I previously told you, it is used for the unlabeled data, which is not labeled. So these algorithms help us to identify the patterns in the data sets which contain data points which are neither classified nor labeled. So some examples are k-means. K-means is the widely used unsupervised learning. You can see k-means everywhere in unsupervised. Other examples are PCA, hierarchical clustering. So these are some unsupervised. So What we learned till now, I have grouped it in two tables. So we will see the difference between supervised learning and unsupervised learning. So supervised learnings will train with the labeled data, whereas unsupervised learning will train using the unlabeled data. So this is the main point. The second point is we can divide supervised learning into two categories, which are classification and regression, while unsupervised can be categorized into two parts: clustering and association problems. So in clustering you can use k-means, which I already told you, and I will also show you the implementation of k-means briefly in the upcoming slides. And in associations you can use like dbscan, pca, all these you can use in association. So now we have got an overview of the supervised and unsupervised learning. So now we will focus on the implementation of every algorithm. So before implementing, we need to know what is SKLEN. So SKLEN is a very useful library for machine learning in Python. Like when we implement every algorithm of classification, regression, or unsupervised learning, we have to use sklearn because this is the tool for machine learning part. Like we can't do anything without sklearn. So we will train our data, we will test our data on different data using different machine learning algorithms, and in each algorithm sklearn library is used. So I have also written that when we separate our data, there are two types of data. First is the training data and second is the testing data. So I will tell you about training data. Like when we build a model, the training data is the data on which we will work. We will divide the data, and test data is the data which will be used for testing. For a real world example, like if we book some ticket in real world, so there are two outcomes. If we work on the like if we cancel the ticket, it will come under the testing of data, and if our booking is successful, it will come under the training of data. So this is a real world example. So after a model has processed using a training set, we can also test our model by predicting values against test set. So one important thing which I will tell you that when we split our data, training data occupies the maximum amount of data. Like generally it is 75-25, or you can say 80-20. So now I will show you the implementation of every machine learning algorithm. So first algorithm we will start is a linear regression, which is a basic algorithm of regression. So regression is used for continuous values. So like if we want a relationship between one or more variables and one outcome variable is required, we will use linear regression. So I have also given some examples, like if we want to find the ages, gender, diet, or height, so these will be used in linear regression. And in our secondary school, primary school, we also learned about slope. Everyone knows that y is equal to mx plus c. So in linear regression, we will follow this equation only, that y is equal to mx plus c, where x will be the explanatory variable and y will be the dependent variable. In easy words, you can say independent variable of, we can say explanatory variable as independent variable also. So this is the implementation. So you can see I told you about sklearn. So we will implement linear regression with sklearn. So like we will write from sklearn.linear model import linear regression. So what this command will do, this will import linear regression library from sklearn. Then after importing, we need to define, like in basic Python also, like when we import something, we need to define it. So in the second code I have defined it, like reg is equal to linear regression. So this is the define of the linear regression. And then after, so these are some basic steps what we do in machine learning. Like first we will import the library, then we will define a model, then we will fit it into a training data set and the testing data set. And after fitting it, we will determine the score, the accuracy of our model. So I have fitted it into a training data set and a testing data set. And in the last, I have predicted the score using testing and training data. So this is a very important concept, like I will tell you. When we fit our model, we will use training, X train, Y train. But when we determine the score accuracy of our model, we will use the testing set. Guys, remember this is the very important basic step. Like I have used REG score, so this is the for testing. So this is the regression, linear regression. Now we will move forward with logistic regression. So we know that linear regression is used for continuous variables, like logistic regression is used for categorical variables. So I have written also that when the dependent variable or target is categorical. So linear logistic regression is mostly used in the classification problems when we need to define some new samples. So for real world example, it is used like when we find the email is spam or not 10, or you can say the answer is yes or no, true or false. And I will also give you some real world example, like when an when any election made when any election is happened and some people stand in the election, so their probability is they will win or they will not win the election. So they will win is 1, they will not win is 0. So this is a type of logistic regression commonly known as binary classification problem also. So you can see the implementation of logistic regression. First I have again imported logistic regression like we did linear regression. So we will import it, then we will again define our model logistic regression, and then we will again fit it into the training data set. And after fitting it, we will again determine the score using the testing set. So CLF.score x test y test. I have written here na x comma y. You can also write x test comma y test. And here you can write dot fit x train y train. I have not written that, but you can assume that fitting is done on training data set and testing is done on, like we will determine the score, so testing. So now we will move forward. So third is the naive Bayes. So naive Bayes is also a classification problem generally known as probabilistic classifier. So this is suitable for binary and multi-class classification. So there are some types of naive Bayes like Gaussian, multinomial, Bernoulli, and each type has its own application. Like Gaussian is used in classification and it follows a normal distribution. Normal distribution, you know, it means that the mean is 0 and the standard deviation is 1. Then the second is multinomial. It is used for discrete counts. Like what we did in regression, linear regression, we will use in multinomial. Third is Bernoulli. Bernoulli is used for like binary values, 0 and 1s, which we did in the logistic regression previously. It is also works on the same application. So if you can see the implementation of naive Bayes, I have implemented Gaussian NB. You can also implement multinomial Bernoulli with the same command only, same code. So I have written from sklen.naive Bayes. This is the library of naive Bayes. Import Gaussian NB. So we have imported our model Gaussian NB with sklen. Then second step, we need to define our model. So I have defined the model. Then the third step, you know, we have to fit our data in the training set, that I have written here gnb.fit extend y-train. So our data is fitted, and now we will predict the score. So we will use testing set, which I have previously told in the two algorithms also you. So this is naive Bayes. Now we will move to KNearest Neighbor, commonly used in KNN. So this is also a simple supervised learning algorithm that can be used in both classification and regression. We can use KNN neighbors classifier, and we can also use KNN neighbors regressors. So this algorithm generally stores all the available data and it will classify the new data point, like you can say new data points on some similarity. So in small words, like when we group something, like I will again give a real world example of this algorithm also. Like when we go into some picnics in school, our teacher group us into some groups like group A, group B. So this algorithm also does this. It will group some data points together on their similarity. So I have also shown you the working of the KNN. So for working, first we need to load our data, which I previously told you. The second step, we need to choose the value of k. You can see now this is k nearest neighbor. So k here stands for the number of nearest neighbors, or you can say nearest data points. So we need to choose the data points, the students, the group of students we need to choose. Okay, so this is the implementation. Again, we will use SKLEN to import our algorithm. So I have used from sklen.neighbors import KNearest classifier. You can also write from sklen.neighbors import KNearest regressor for regression problems. Then we need to define our model, and during definition we will need to remember one thing, that we have to also give the number of neighbors, like what is the number of neighbors, what is the number of students I told you in the example. So like I randomly gave 3, you can give any number from 0 to 1, 2, 3, any number you can give. And then the obvious step, you need to fit our dataset into training and testing. So that I have did. Then we will move towards support vector machine, generally known as SVM, and these are also used for classification regression both. And one common application of SVM are that they are used to detect outliers. Now you will say, what is outlier? So outlier are some data points which behave very differently from the other data set. Like I will give you some example, like if there are some ages of random ages of female and male, like ages are 30, 35, 40, 60, these are the ages, and in that ages column there is one value like 200, 250. So this is not possible now, that someone ages 250 or 200, this is not possible. So this is called outlier. So for the better accuracy of our model, we need to remove that outliers, or we can also do, we can replace that outlier with some value which is in the range. Like we can replace 200 by some value like 40, 45, or we can completely remove that value. So this is something about outliers. So some advantage of SVM are that they are effective in high dimensional spaces, that they are used for a large space values. And so these are some examples, and each value lie in the target values that I already told you. Each value will lie in a specified space only. So you can see the implementation of SVM, like from sklen.svm import SVC. SVC means support vector classifier. You can also use SVR, which is support vector regressor. Then after importing, we need to define our model. So we will use CLF SVC gamma. So I will now, you will ask what is the meaning of gamma. So gamma is just a variable which we use during the definition of SVC. So like gamma is the value which is of the target value. So you have to use during the definition of your model. You can use different values, like I use gamma auto, you can use RBF, you can use linear. So these are the values, and then you have to again fit your data model into training and testing. So now we will move towards decision tree. So decision tree is a very famous algorithm of classification. Like we all know about DSA. In DSA, when we made some tree, so some tree has roots, then it have leaves. So that mechanism only decision tree follows. Like I will show you example. Like there is some tree. So a tree, on the top of the tree, we will say that it is the root, and then we'll slowly come downwards. We can see the leaves of the tree. So this is the mechanism of decision tree, that we will create a model which will create a target variable using different flowcharts, like flowchart of tree structure. So from this, like when we start from the node, we will slowly come towards the end. These are the called leaves. So this algorithm can also be used for classification regression. So decision tree generally we use when we required some tree problems. Otherwise, we can also use random forest, which will be discussed in the upcoming slides. So I have also shown you the implementation of decision tree. So we will import first from sklen.tree import decision tree classifier. So this is how we import the decision tree module. Then we will again define our model. So during, oh, I forget to tell one thing. So there are two things in decision tree. First is impurity, second is information gain, and these both terms we know in chemistry from 12th class only. Entropy is simple, the randomness of order, and information gain is the summation of all the entropy values. So one thing you have to remember, that when we create a decision tree, our entropy should be minimum and information gain should be maximum. And this follows the rule, like when we come from the root element, our information gain is maximum and, sorry, our entropy is maximum and information gain is minimum. And when we come slowly towards the leaves, our entropy will decrease and information gain will increase. Then only we need to stop. So this is what I have written: random state 0 and criterion entropy. You can also write criterion as information gain. I have used criterion as entropy. And random state 0, you will ask what is random state. So we use random states so that our data don't change frequently. Like I have given any values 10, 20, 30. So if they will frequently change, my model prediction, my accuracy will suffer from that. So I have used random states so that my accuracy don't change frequently. And then the third step, now we are very familiar with it. We need to fit our model into training and testing. So now we will move forward, and now we will come to random forest algorithm. So random forest is also a very famous algorithm used for bagging and boosting part. So this is also supervised machine learning, and we can use in both classification and both regression. And nowadays many people are using random forest algorithm because of its high accuracy and model score. So for example, if on the same dataset we use the algorithms which we previously studied, like decision tree, naive Bayes, KNN, or regression algorithms, and on the same dataset we use random forest, it will give you a very high accuracy than the other algorithms. So that is why it is very famous, because it performs very well on every dataset. So I have also written how we build random forest. So random forest builds multiple decision trees and merge them together to get a more accurate and stable prediction, which I told you, that decision tree which I told you previously, we will combine all decision tree together and we will get a more accurate and stable prediction. So I have written the general idea of bagging method is combination of learning that increases the overall result, which I told you that overall result increase means that the accuracy, the score will be high. Oh, like I will give again real world example of this algorithm also. Like when there are exams are in school, when we were in 12th standard and there were exams in our school. So like one student prepares very well for his or her exam and then appear in the exam, so obviously he will get a good score. But if the other student who that didn't prepare for the exams and then he appeared for the exam without preparing well, so obviously he or she will not get a good score. So this is what random forest focuses on a good overall score. So I have again shown the implementation. So from SKLEN ensemble, import random forest classifier. So now you will ask what is ensemble. So ensemble techniques are some bagging and boosting techniques. So all these like random forest, we will study about gradient boosting, ADA boost in the upcoming slides. All these are the ensemble methods. These ensemble methods focuses on the high accuracy of model. So then I will again define my model. You have seen CL random forest classifier and random state, you know, I told you what is it, and we have introduced a new variable here, max depth. Max depth which means that how depth, how deep we want to go. Like we start from the root node, so how deep we want to go to the leaf node. Like we want to go only one step, two steps. So my max depth is 2. So I will go 2 steps downward. So this is the definition. Then again we will fit our model into training and testing. Now we are very familiar with the training testing part. So now we will move forward and now we will focus on gradient boosting. So gradient boosting is another ensemble technique only like random forest, and it also focuses on the high accuracy score. This is also written most powerful algorithms in machine learning. So gradient boosting can be used for both again regression and classification problem, and this will combine all the decision trees to create a final prediction like we did in the random forest only. It will follow the same procedure. So I will show you again the implementation. So again we will implement it like the way we imported random forest. So you can see from sklen.ensemble import gradient boosting classifier. So this means that we have imported our model like random forest classifier. You can also import gradient boosting regressor if you want for regression. Then again we will define our model like I have defined gradient boosting classifier. We will give n estimators. So now you have to focus on the steps that I will told you. So this n estimators, learning rate, max depth, random state. So you already know about max depth and random state. So I will not repeat about that. So I will tell you what is learning rate here that I have given 0.1. So learning rate we generally use in gradient boosting. So that this will be like this will act as a parameter to optimize our algorithm when we start from the root of the tree, and when we go down till the leaf point we need to find the minimum function. Like for real world example, if we are assigned some work, we try to do in the minimum time only for the benefit of ourselves. We will not procrastinate it, we will not take maximum time, we will try to do in the minimum time. So this is what the application of learning rate, that it optimize every step of our tree and it will minimize our function. So this is something about learning rate. Max depth and random state you know, and n estimators mean like you can say random data points I have given of our model. So you can change, you can give 50, 70. I have just given randomly 100. So then again we will fit our data into training and testing, and then we will predict the score using testing, X test, Y test. These all things we know. Now we are familiar with these. So now I will focus on the next slide. So we have completed the most of the classification and regression algorithms. Some we can also learn some more ensemble techniques. We focused on two techniques only, random forest and gradient boosting. We can also learn about ADA boost or XG boost, which is known as extreme gradient boosting, or extra trees classifier. So these are some advanced algorithms. We will not focus on these algorithms. So supervised learning part is done. Now we will focus on the unsupervised learning. So I have implemented k-means. K-means is the most famous algorithm of unsupervised learning, which is widely used to several groups to group several similar values together. Similar values, like I will again give you a real example. Like if there are some grades like A plus, A, B, B plus, and we are told to group like the people who got A plus group in some one group, then we need to group some people whose grade are A. So we will group those people A. Then we will group some people whose grade are B. So in that group only people with B grade will come. Then we will group some B plus people. So all these people are grouped in different groups. But the main point here is that we will focus that in the A plus group people, there are only people present whose grade are A plus only. The A grade people can't come to the A plus group, and similarly the people whose grade are B plus can't come into the group of B. So this is what k-means do. It will group similar entities together. You can also see what is written in the definition, that data points are clustered with each other and similar entities will be together but enclosed in different groups. This is what I told you. So k-means will be used on the unlabeled dataset. The algorithms which we used till now were of classification regression that were used under labeled dataset. And this is the algorithm which is used for unlabeled dataset. So now we will implement this algorithm. So first you will define our algorithm from sklen.cluster import k-means. So cluster means clustering. So this is unsupervised learning and we will import k-means from sklen.cluster import k-means. So this is the importing part. Then again we need to define our model. So in define we will use k-means. We will again give random state which we know that it is used so that our data does not change frequently, and n cluster or n variable. You can see here I used n variables in the previous algorithm, and here I have used n clusters. Clusters are just the group of people. Like if there are two groups, you will use two groups. If there are n clusters equal to 3, means if there are three groups, you will use 3. So this is just, and then again we will fit our model into training, and then in the last we will predict the score using testing dataset score.xy. So these are some algorithms of supervised and unsupervised learning. We learned about classification and regression problems, and we learned about unsupervised learning. There are more algorithms used in unsupervised like DV scan, hierarchical clustering, PCA. So that implementation you can Google it, or you can also see the SKLEN implementation in the documentation. So this was all for this video. Thank you so much.